Okay, so the last one in this worksheet, pos tagging a new sentence. So I think the giveaway's in the title, so we're going to apply pos tagging to some new information that we have, and obviously we need to base that on some old information that someone's already tagged, right?
Yes, because we're going to use the unigram tagger, which does not consider context of the sentence that you've passed to it. What the unigram tagger does is it takes a training set, a very large training set preferably, and it calculates the frequencies of each word.
So in the previous
tag.
example on the race, it would make a hard decision one way or the other.
Yeah, it would decide based on 94 that that's going to be the most likely.
Yeah,
probability is back in here. The probability of the word race being tagged as a noun is greater than being tagged as a verb.
Yeah.
So let's tag it as a noun.
Okay. So this is a bit like artificial intelligence. You take a bunch of information that you already have. You're going to train, in inverted commas, your new information based on the old information, and you're going to spit it out, and it'll all be probabilistically based, right?
Yep.
Okay, think I've got it?
Okay, so to do this, we first need to train our unigram tagger. Okay, so we need to have some sentences to pass to it to give it some training. So it says in here on number 6, first let us train a unigram tagger using 5,000 sentences of the Brown corpus as training data.
Okay, well that's baby stuff, isn't it? Because we had 1 million just now, so 5,000.
Yeah, and we're going to, the categories equals news argument selects only the news documents from the diverse collection within Brown. Yeah?
Yeah.
So we've already imported Brown on the previous,
So
so I don't need to do that. So I'm going to create a variable called unigram tagger, yeah, and in there I'm going to create a trained data set. So I'm going to say NOTK library, right, and I want to go into the tag class and I want to use the unigram tagger, yeah.
Okay.
And into that unigram tagger as training, I want to send from the Brown, from the Brown tagged sentences, not words this time, so sentences, yeah, and I want to filter that as categories equals news. So I only want the news categories to be considered,
Yeah.
and I want to go
First
from the
5,000.
beginning to 5,000 sentences, not words.
Not words,
yeah?
yeah.
And then I want to close my bracket there. Okay, let's do some training, nice and quick.
Yeah.
I wish AI training was always that quick.
Yeah, usually takes days, doesn't it?
Okay, so now we're going to inject our sentence. The Secretariat is expected to race tomorrow, and we are going to see how it gets tagged. Now, John, based on our previous experiment, what do you think the word race is going to be tagged as using this model?
I think it's probably going to be a noun. Yeah?
Probably going to be a noun. Okay, let's have a try.
But I'm not going to bet another lunch on it because it's already cost me.
Double or quit.
Yeah, all right, yeah, double or quit. Yep.
Import word. So now I'm gonna import the word tokenize, which we've used before. So
No, you're not, 'cause you broke
that
that.
wrong. TKNIZE, import word underscore tokenize. Oh, sorry, I put work and not word.
You did, yeah.
So there's a little typo. Okay, now we're happy. We're going to create a sentence, and in that sentence we're going to write this.
The Secretariat is
See if I can
expected
copy
to
that
race
from
tomorrow.
here. Okay, so if I can copy and paste that and check the syntax. Yeah, looks good. Yeah.
So,
Okay, so we have that as a sentence, and then we're going to create the
We're
a
gonna
variable
tokenise.
to capture the tokens
Yep.
from our tokenizer,
Yep.
and we're going to go word.
and we're going to pass to
Underscore
its S,
tokenise.
which is the sentence.
And we're going to pass S. So we've done this before. We've taken S. Let's have a look.
Yep.
Let's just have a look
S.
at print S underscore talk. See what it looks like. So nicely tokenized. Yes.
Yeah.
We've done this before in
Yeah.
previous labs. Yeah. So now I'm going to
Now
pass
we've
that
got tag
tokenizes into our tagger.
This is standard procedure all the time, isn't it? We
Yeah.
tokenise, tag using various means, and then after that we're going to search the tagged corpus. You know?
Yeah. So I'm gonna use the tag member. Yeah. And I'm going to send to it my tokenized
That's
sentence.
not fair, no.
I'm going to send to it my tokenized variable that I have just created. Yeah?
Yeah.
And there we have. So let's have a look. What is the race to be tagged as?
It's a noun.
It's a noun.
So I haven't got a violence.
Hey, you got away with it. So did you guess correctly? Yes, you did. Okay. So quite interesting, and that shows you the step-by-steps on how to take a sentence, how to train the Unigram tagger, and how to, obviously, a different set of training data might give a different result on that. But probabilistically, we're not sure.
Yeah,
You know?
okay.
So now we will use the HMM tag, the hidden Markov
model.
tagger.
So you've gone through this in the lectures. It's
Yes.
a series of circles based on probability. You can go from one circle
Yeah.
to another circle or back again,
Yes,
depending on
that's right. So
the
it's like,
sequence of events that's happened
it's
previously.
like a state machine.
Like a finite state
Yes.
machine, yeah.
Okay, so we're going to, and of course, as it says here, it takes context into account, not just the probability of a word getting a tag. It's actually going to look at the context. So,
now, context as in news or context as in the place in the sentence?
as in the place in the sentence, it's going to look at the sentence, the context of the sentence, and decide whether a verb or noun can be assigned
Should be at that
based on
location.
the context of that sentence. Exactly. So let's plow ahead and let's create a HMM tagger variable, and in this time, right, we're going to, in the NLTK library, if I spell that right, NLTK library, we're going to look at the HMM class, and inside the HMM class, I'm going to invoke the trainer, right, which will be the hidden Markov model. It's possibly this one, tagger. We want the trainer. There we go. Hidden Markov model trainer, and then in that trainer, yeah, I'm going to call the train supervised member. Supervised.
Okay, so we're still in the training phase of this, aren't we?
Yeah.
So we're gonna.
And I'm going to send my same training data that I used up here. The brown tagged sentences categorized in news. Yes.
First 5,000.
So I'm going to send that to this this training model, the HMM training model. Yes.
Yeah.
Okay, let's run that. Okay, so now we've
Okay,
trained our
yeah,
HMM
yeah.
tagger, and now I'm going to send to it, right, our tokenized, untagged tokenized string that we generated using the word underscore tokenize. Yeah.
Yeah.
So, and that's called
And
stop.
we've already written that, so we don't need to do it again. It's still.
Okay.
Yeah.
What do you think it will get? So this time.
I don't know.
Lunch
No,
could be
no,
back on here,
yeah,
couldn't it? Eh?
I still think it's going to be a noun.
You think it's going to be a noun? Okay.
Took longer.
Yeah, it definitely did. Now it's a verb.
Oh.
Lunch is back on. So that's interesting to see now how that's taken a context into account, isn't it? It's
Isn't that
very
odd?
interesting.
Isn't that odd?
And powerful.
Mm.
So try both the Unigram and HMM models to tag another ambiguous sentence of your own, which you can do by
Yeah,
yourselves.
absolutely.
We've shown you the route of how to go right from the beginning, tokenize, training, and then having a look at it.
And just looking at the sentences, British left waffles on Falkland Islands and juvenile court try shooting defendant.
Yeah.
You see, that's an example of context. Sorry, I just pick up on that. But you could read that sentence either way in meaning, couldn't you?
Yeah.
British court to try shooting defendant, so someone has shot someone, or they
I
can
mean,
try shooting him.
It's full of ambiguity, isn't it?
Yes,
Full
which
of
is the beauty
ambiguity.
of language, I guess.
Definitely. Okay, so that's it, and it's a good time to go for a free lunch. So thank you very much.